Okay, so let's review for the final. Let's do a little bit of practice on multiple choice and practice some skills that we would need to look at here. So in this problem, we have 21x cubed. And if you try to attack this problem straight on, you could end up wasting time. Okay, what I notice here is a bunch of plus fives, and we see a bunch of plus fours and only one minus four. So if you are paying attention, you should be able to notice that a positive 5 times a negative 4 is going to give me a negative 20. But all of these positive 5s times positive 4s would always give me a positive 20. So that means that this could not possibly be, none of these could possibly be the answer. So I could eliminate B, I could eliminate C, and eliminate D. And we could choose A as our answer. Okay, this would be the answer here. If we took a look at this expression, n squared minus 8n plus 12, we could go back and try to remember what it meant to factor using our magic X, right? We could try to factor this thing, and let's reactivate some of that knowledge. This could be something that you might want to add to your note page. Okay, just a simple factoring problem like this. We want two numbers that have a product of 12 and a sum of negative 8. Okay, this is what we're trying to find. Now, if we look at these numbers right here, don't forget that they're already right in front of you. There's some options to choose. So, does 1 times negative 5 make positive 12? That's not true. But what about negative 6 times negative 2? Does that make positive 12? And it does. And if I add these together, would I get negative 8, right? And because we see that this leading term is positive and this term is negative, that was the case where you guys were supposed to remember, like, hey, both of these are going to be negative and they're going to have to add up to 8. And so that means that I would have 2 and 6. Okay, so negative 2 and negative 6. And we'd be able to confidently choose C here, okay, because this is just our option right here, right? A negative 6 times negative 2 is going to make a positive 12. None of these other options even seem like it's possible, okay? And then so you might have to wrestle with this idea, is this one not factorable? Well, maybe you should try to factor it for a second and think about it. Or you could just multiply this out yourself and say, wait a minute, let me try to multiply that. Let me try to do n minus 6 times n minus 2. And so to review some of the basic skills that we learned this year, right, we would get n times n, and that gives us n squared. We would do n times negative 2, and that would give us negative 2n. Then we could do 6 times n, and we could say that's going to give us negative 6n, right? And then here we have negative 6 times negative 2, which would give us positive 12. And if you combine like terms correctly, you should be able to see that this is going to give us, okay, again, that got a little messy right there. I'll try to fix that. But still, you get my idea, right? All we're doing is verifying that this makes sense. But negative 2n minus 6n, you want to make sure that you realize that that's going to be negative 8n because both of them are negative. And so since you can see that by multiplying out this term, we got what we started with, this would be the correct answer. This would be factored. So at this point, we've done this problem, and we could go move on to another problem below. Okay, we have this problem right here, which is x squared plus 13x plus 36. So think about it. We're looking for something that will give us a positive 36. I see a negative 1 times a negative 9. If I multiply a negative 4 times a positive 9, which would give me a negative 36. But I see positive 4 times positive 9, which would give me a positive 36 if I multiply those. So, if you understand factoring, you should be able to quickly choose D as your answer. And that would be able to help you out because you don't actually have to spend too much time guessing and trying to think about the numbers and making a list of all the factors of 36. I mean, 36 has kind of a lot of factors, right? 1 times 36, 2 times 18, right? You can keep going down the list, right? 3 times 12. in this case, you have to choose one of these. So, I mean, the answer of D would be something that is kind of jumping out at you, right? 4 times positive 9 makes 36. And if we add 4 and 9, we get 13. And so this would be factored correctly if we were going to do this one. Now, if we take a look at 13 here, we see that we have to factor something with the leading coefficient, okay? And that makes things a little different. And I noticed that we have positive 8 times negative 6 does make negative 48. And we also have negative 8 times positive 6 that makes negative 48. So we know we could get rid of B. And we know we could get rid of D. And that's good news, because that means you could avoid, ending up with the 24% on this 25% by just guessing, because it's 1 out of 4. And so if you just guess on all these problems, that's going to be what happens. You're going to end up with a random score that's 1 out of 4. If you can at least eliminate a couple options, you're making your life a little easier here. So we're trying to choose now between C and A. So there'd be 2 ways to do this. One way would be to go through and multiply these out and see what you get. Or another way would be to factor it the way that we learned from the magic X, right? We can go through here, set up the magic X. We could say, okay, I got to do 3 times negative 48. And you realize, okay, well, that's going to be a big number. So is that what you want to do? Do you want to have to do this calculation? Or would you rather go through here and multiply one of these out and see what you're going to get? So that's up to you. If you want to just use the magic X and just jump straight into it, you can do that. Okay? Let's see what happens if we try to go straight forward and just check each one. Okay? 3x times x is 3x squared. And if we do 3x times negative 6, then that would give us negative 18x. And then we would do 8x. 8 times x gives us positive 8x. And last, we would get positive 8 times negative 6, which would give us negative 48. So we could deal with this and realize that negative 18x plus 8x would give us negative 10x and not positive 10x like we need. We could see that this problem is the other way around. So we could actually eliminate A. We could double check our work a little bit to make sure, hey, did we have the right sign here? Is this really supposed to be negative 18x? And look again, right? 3x times negative 6, that does make negative to 18x. So since the negative number is smaller, we're not going to end up with positive 10x. So you could confidently choose C just because you evaluated one of them, okay? If we did it the other way and went through and just, tried to use the magic X, then some of you guys might even write the wrong number. You might try to do 3 times negative 48 and say, okay, that's 120 plus 24, so then you got 144. And 144, maybe you'd forget to include the fact that this would be negative 144, because we'd have to do 3 times negative 48, right? Because don't forget that we have to do A times C up here, and then B would go down here. So we'd be looking for factors of negative 144 that add up to 10. And then after we found them, we'd have to divide by our leading coefficient of 3. And if we did it that way, we could mess around with it for a while before we find the answer. So again, you want to try to not waste time. And so because we have these options here, you can just immediately attempt to solve the problems that are in front of you by going straight through and just actually working with what you have. So if we take a look at 14, more factoring practice here, this expression has no constant term, and so that's not something that we can analyze right here. So you can notice that if we did multiply a 5 times a negative 9, and then everything would have to be multiplied by 3, there would be a constant term. So we can't really have that here. What you guys should think in terms of this one is just a pretty straightforward factoring skill, is what common factors do we have in these things, right? 12 is equal to 4 times 3 times V times V. And 8 is equal to 4 times 2 times v. That's 8v. So what do they have in common? You know, both of these have a 4, right? That was why I actually chose 4 times 3 instead of just doing 2 times 2 times 3. I saw this one also was a factor of 4. I could notice the greatest common factor of these two terms was a 4, but also a v. So that means that I could factor out a 4v from this expression, and what would stay inside there in this case would be the other ones that we didn't factor out, right? So I could use another color to see if we can represent this a little better, right? We see that I have 4 right here and a v in common. This has a 4 and a v. So what do they not have in common, right? There's 3 and that v would go right here. And because there's a 2 that got left out, that's why this would be plus 2. And so we should be able to see which one is the answer. In this case, we would choose A. Okay, and we would say that we factored out 4v from both of these because 4v was the greatest common factor. So again, you could try to multiply these all out and see what you get. That'd be another way to do it, right? You could just go straight through and try to work with what you got. I'm going to erase my work that I had here. If you want to see that again, just rewind the video. But what we're going to do right now is, try to go the long way. What happens if you go the long way? Okay, well, luckily the answer was up here. But let's assume we started at the bottom. Then what would we get if we did this one? Right? So here we'd have 4v times 3v, and that would give me 12v squared, right? Because I have 4 times 3 and v times v, which is by definition v squared. Then we'd have to do 4v times negative 2. So don't forget that 4 times negative 2 is going to give us negative 8, and then we have to include the v. So this obviously is not equal to what we have up here. So this would not be the answer. Then we could try this one. Okay, and we could see that 3 times 4v would give me a new expression, right? That would give me 12v. And then if I do 3 times 5, that's going to give me plus 15. And now I'd have to take this and multiply that by the 2v minus 9. And if I multiply this, eventually I'm going to have to do 15 times negative 9. And that's just going to be a number. That's going to be a constant value, right? And we don't have any constants in this expression. So like I said earlier, we should be able to rule that one out too pretty quickly. Okay. The next thing that we would do is to inspect that last one and see what we get. If we were to look at this one, we would see 12v times v is going to make 12v squared. And to do 12v times 1 means to just add 12v again, right? 12v times 1 is just 12v. You multiply something by 1, it doesn't change. So we got 12v squared plus 12v. And we can see that is not what we have up here. So this is also not the answer. So think about it. If you eliminate 3 of them, you have found the answer by process of elimination. So now we can take a look at 15 and see what we get. We got 24v squared minus 486. So in this case, this number is much bigger, right? Maybe even a little scary to some people. This might be a good time for you to pause the video and try to do this on your own and see how you're doing. See if any of these factoring things is making sense. Try to find the answer before I show you. But we can go work on this once you're back and you've tried on your own. So hopefully you did that. If you didn't do it yet, pause the video now, right? What's 7 times 8? That's 56. And so as we've seen from looking at factored forms, the constant terms are going to come from us multiplying the two constants. 7 times 8 is not negative 486, so it can't be the answer here. Positive 3 times positive 7 is also not equal to a negative 486. So this means we can also rule out C, right? Next we have B. And if we look at B, we can see that we would have to do negative 9 times positive 9. And then that would give me a negative. And then I would actually have to multiply that by 6. So, you know, maybe we could go look at this one more time. And you guys should see, wait a minute, we're squaring, right? So what does that mean? What does 2v minus 9 squared mean? That means 2v minus 9 times 2v minus 9. So again, we're going to be able to avoid doing the harder calculation, because think about it. What's a minus times a minus? What's minus 9 times minus 9 going to give us? That's going to give us a positive 81. And if I multiply that by 6, I'm still not going to end up with a negative number. So the option in this case would be B. This would be the option that you'd want to pick, okay? So like I said, we're learning how to analyze these options and how to rule out some of the non-examples, some of the distractors, as we call them, because those are not the correct answers. Okay, they're meant to distract you from finding the correct answer. So don't get distracted by them. Just one at a time, go through and eliminate them. So if we look at 16, we see a couple things that look like they might be perfect squares. And here we go. We're going to take a look at this specific form on 16. We can see here that a negative 1 times a positive 1 would make a negative 1. So we wouldn't end up with this positive 1. So we could cross out this example right here. D could not possibly be the answer. And then if you think about v plus 1 squared, by now you guys should understand that that's going to just be v plus 1 times v plus 1. And so our form for this, if you want to take the time to write it out, I'm hoping most of you guys would just look at that and not even waste your time doing it and realize this is not going to be even close, right? Because v times v is going to give me v squared, not 16v squared. So you'd cross that one out. Okay, and then realize, wait a minute, 16v squared, which one of these is going to give me that, right? Can it possibly be 2v plus 1 squared, which would mean 2v plus 1 times 2v plus 1? If I multiply that out, I'm going to get 2v times 2v, and 2 times 2 is 4, and v times v is 4 squared, v squared. So we get 2 times 2 is 4, v times v is v squared, and not 16v squared, and therefore we could cross that one out. So you can see that the answer will be v, where we would end up having v, the coefficient of v would end up being 4 times 4, right? We're going to end up with a 16v squared because we have 4v in this case. So you would choose B. Okay, so now that we're here, we can move on to 17 and kind of get out of the just factoring problems and move on to solving by factoring. We look at A, we have positive V times negative V. That makes negative 25, and we need to get a positive 25. So we know it can't be A. Then we have this possibility here where we'd have 3a plus 1 squared. Okay, but again, this one would give us 3a plus 1 times 3a plus 1, right? And so you shouldn't let this one fool you either, right? 3 times 3 is going to give us 9a squared. 1 times 1 is going to give us 1. I mean, we don't have anything close to what we need up here. So we would go ahead and cross out B. That's not even close to being true, right? 3 times 3 would give us 9, and a times a would give us a squared. Of course, we would have to multiply all the other ones out, yeah? We would have to look at 3a times 1, which would be 3a, and then we have to do 1 times 3a, which also gives us 3a. But last, we get 1 times 1, so I hope you guys can see why I'm kind of skipping these, right? Because we just wasted a bunch of time, right? The quadratic term is going to come from multiplying the two linear terms. And the constant term comes from multiplying the two constants together. So we know we're not going to end up with this. Okay, same thing here on C. We can tell this is not the answer. It's not possibly going to be the answer. If we square this, we get a minus 3 times a minus 3. And there's no way that this could possibly be the answer, because if I do negative 3 times negative 3, that would give me a positive 9, not a 25 like I need. So again, I could cross this out. And if you wanted to double check, you could do the math and take a look at it, right? 4a minus 5 squared means 4a minus 5 times 4a minus 5. And if we do 4a times 4a, that gives me 16a squared. 4a times negative 5 is going to give us negative 20a. Negative 5 times 4a is also going to give us negative 20a. And the negative times a negative, right, makes a positive. So negative 5 times negative 5 gives us positive 25. And you can see that this looks a lot like this, except for it's not been simplified, right? And if you could realize that if we simplify this, we would have exactly what we needed, which would be negative 40a plus 25. So there we have it. Okay. So I think we looked at 18. Maybe a couple classes we're ready to jump straight into solving by factoring. Some people saw fractions and got scared pretty quick. So, don't forget what it means to solve an equation in general, right? Solving an equation means find the numbers that make it true, right? And we are solving these equations. So that means we want to find the numbers that make them true, okay? So they're giving us this ordered, not an ordered pair. What it's giving us is in curly braces, right? This symbol right here that we call curly braces, okay? Braces, okay? Inside of these braces, we have two values that would represent the different solutions to this, okay? When we solve by factoring, we would usually set our equations, each factor equal to 0. So the way you would solve this would be you would write x minus 4 equals 0, or x plus 8 equals 0. And this was called the zero product property, right? We knew that if I multiply two numbers, a times b, and I get 0, then that means that one of them has to be 0, right? Either a is equal to 0 or b is equal to 0. And that's why we said, hey, if this expression, x minus 4 in parentheses times x plus 8 in parentheses equals 0, then that means one of the things in this parentheses must equal 0. And so that's why we have to set this equal, and we get two different answers. In this case, we solve a pretty quick equation where we'd add 4 to both sides, and we would end up with x equals 4, positive 4. And we could see only one of these even has positive 4 in it, so we could already bet that that's the answer. But then here, we take 8 from both sides and get the x equals negative 8. And there we go. We get the answer. So now looking at number 19, we have a couple ideas to do here. One of the ideas is, well, find which number would possibly make it true, okay? What number can you subtract 1 from and then square it, and then you get 0? Some of you guys might be afraid to go through and do the work, but it's not really that much work. In this case, we can solve this by doing square roots, or you can solve it by factoring, which is what this section is kind of implying, is that this equation on the left-hand side says n minus 1 squared, and like we just saw a second ago, what's that really mean? It means that we have the same thing written twice, right? N minus 1 times n minus 1. So in this case, I could set both of these equal to 0. And like I said, this was something that might go on your note page, right? This process. So if I add 1 to both sides, we will end up with this idea that n equals positive 1. Or, well, this is the same equation. So obviously I'm going to get the same answer. We get n equals positive 1. So the answer would have to be A, and in this case, there's only one possible answer, right? None of these other numbers, if I put them in there and square them, am I going to get 0? And think about it. If you square a number and get 0, that means that the number that you squared was 0. So the only number that you can take away 1 from and have 0 is 1, right? 1 minus 1 makes 0. So you'd have to go with that one. So, try to use your powers of deductive reasoning on these ones. You do not want to just guess on this test. It would not be a good strategy. Okay, you can figure these out just by using what you've known. We've done so many problems here. You should be able to handle this. If you take a look at number 20, we have two equations that need to be set equal to 0. Okay, so these are both factored already. It's in factored form. And so now what we could do is set 8p minus 3 equal to 0, and write or 2p minus 3 equals to 0. And then we solve them. All right, if I add 3 to both sides, then we get AP equals 3. And if I divide both sides by 8, it would be able to cancel out these 8s and end up with the final P equals 3 over 8. On this side, we have plus 3 from both sides. That would be the first thing you want to do. And then now we have 2p equals 3, and if I divide both sides by 2, we end up with p equals 3 halves. So you can see that we have two answers. We want to choose positive 3/8 and positive 3 halves, and that answer would be D. So that's one of the first times in this video where we've just gone straight through and did a problem instead of analyzing all the answers. Okay, I think that might have been a waste of time because this problem's pretty quick. Okay, we could have gone to go try plug in -2 and see if it makes this equal to 0 or this one equal to 0. That's one way to do it. Okay, we could try -3 and plug it into any of these numbers and realize that that won't give us 0, right? If I plug in -2 for p, 8 times -2 gives us -16. -16 minus 3 is in 0. If I plug in -2 here for p, then -2 times 2 gives me -4, and -4 times 3 does not give me 0 either. So you could have solved these also by process of elimination, but it would not be the ideal thing for you to do. So just please, you got to choose wisely how to use your time. And that's why in a case of a problem like this, my instincts tell me just go ahead and solve it, because it's going to be a two-step equation and you just get the right answer. Okay, sometimes you might see problems where it's a little more complicated and you're not quite sure what to do, and so that's when you start doing the analyzing. When you see that you're going to waste a lot of time one way or the other, that's when you start analyzing the answers. If the problem looks something that you can do straight away, then just go for it. Okay, in this case right here, we have a lot of different options. Okay, we can solve this by factoring, or we could try to substitute these numbers in and see if they give us what we need to get. Okay, I would recommend solving this one by factoring. Okay, because we'd have to just figure out what that's going to be. So in this case, we can go ahead and just do what we got to do, right? We're going to make sure that we have, give me a second, the mic is the mouse isn't responding right now. So the idea for this problem would be, let's factor it, right? Might as well review it because we're here. Okay, so don't forget that we want two numbers that multiply up to AC and add up to B. Okay, in this case, A times C, well, A is an invisible 1, and 1 times -3 makes -3. B is equal to +2, so we have a 2 right here. And then if we go through and do this, factoring process, is not a very long list of numbers that multiply up to 3. We got 1 times 3 when we're using integers, and that's pretty much the only option that we have, right? We know one of them's got to be negative and one of them's got to be positive. And then like we made our decision-making process before, right? Think about it, like which one will be the negative one when our linear term is positive, right? It's +2. So that means that our bigger number must be the positive one and the smaller number must be the negative one. So that means that if I was going to factor this, I would write p minus 1 times p plus 3 equals 0. So see what we did here, we factored this expression, it's still set equal to 0. And so now to solve the problem, we set each of these factors equal to 0. We do that one or this one. And now we get a quick one-step equation, right? I add 1 to both sides, and we get P equals 1. We take 3 from both sides, and we get P equals -3. So we would choose which one has both of those together, and we can see that there's only option D that has both of those solutions there for us. So again, solving by factoring was something that we covered for a while. We had a test on it even. And I know some of us might have, maybe you forgot to study, maybe you did study, maybe factoring was something that you did not enjoy, and I think a lot of people didn't really like it. Because again, factoring is like dividing, and dividing feels really backwards and unnatural, and so it can give you a headache a little bit, right? So we'll take a look at 22, and then I think we'll be into another section of the test. But, you know, if you remember the steps of solving by factoring, right? We had several steps, right? We have step 1, we have step 2, we have step 3, we had step 4. We had many steps that I used to solve by factoring, okay? But I like to call this first step, step 0, okay? Because when we're solving by factoring or solving by quadratic formula, we needed to have our equation set equal to 0. So the first step is really step 0, right? Is set the equation equal to 0. And what does that mean? That means that we have to do whatever calculation it takes to end up with 0 on one side of the equation. It really doesn't matter which side we put this, okay? But I know a lot of people are used to seeing the equations written one way. So you got to kind of, you know, get rid of that superstition and just realize we just have to set it equal to 0. So if I take 2x from both sides, if I do -2x on both sides, we have 0 on the left side. And I know a lot of times we write it on the right side, but that's fine. We'll be okay. Okay? This is why we learn things like standard form. Okay, I taught you guys earlier in the year that the standard form of an equation is just, you know, starting with the biggest exponent and having the exponent decrease. Okay? 0 equals this. We can easily just rearrange this and write the 0 on the other side, right? So I could just as easily put the 0 here. What's the difference? I mean, there's no difference, okay? And now we could go ahead and erase this. It doesn't matter that the 0 is on the left instead of the right. You can always just move that over there, okay? So that's one time that that has meaning. You could just go ahead and 0 being on the left or on the right doesn't matter. Still equal to 0. It's the same expression. So now what we could do is write it in standard form. Maybe that'll help you, right? We have -3x minus 2x plus 1, because this one is positive, not negative. These two terms are negative, so they stay negative when I rearrange them. So we set it equal to 0. That was our first step. Now what we did is, you know, something that I usually leave this step out. I didn't really have you guys rewrite it into standard form. But in this case, we did it. We rewrote it in standard form. And we didn't have too many problems on the test that dealt with that. So I know we rewrote it in standard form. All right, so I'm just going to go ahead and abbreviate that right there, okay? In standard form. And what was that about? Why did we have to do that? Well, because we wanted to have our A, B, and C and everything so that we understand what that is, right? Because when we do our magic X, we know that we have an A and a B and a C and everything, okay? And the idea is that they have to multiply up to AC, but they have to add up to B, okay? But we have all our terms in a certain order, so we're kind of used to seeing them like this, right? A is the coefficient of the quadratic term, B is the coefficient of the linear term, and C is the constant. So if I do 1 times -3, that gives me -3. I'm looking for two terms that multiply up to -3, and they add up to -2. Okay, again, numbers that multiply up to -3 aren't too hard to find. We know we gotta have 1 and 3 because they add up to a negative. That means that the 3 is negative and the 1 is positive. Okay, But when we're using magic X, okay, we always have to divide by our leading coefficient. That's a step that you can leave out sometimes when it's divided by 1. We don't have to dwell on that too much, but when your leading coefficient is not 1, you got to actually simplify and fix that. Okay, so what's negative 3 divided by negative 3? That's positive 1. Whereas this other one is going to give us negative 1/3. That can't be simplified anymore. So what we just did here is we're ready to factor it now. Okay, so we rewrote the equation in standard form. I did teach you guys before to factor out the GCF, the greatest common factor. But in this case, there is no greatest common factor. So we factor out the greatest common factor if it's possible. Okay? If it's not possible, then obviously don't do something that's impossible, right? Don't try to do something that's impossible. Move on, okay? So what I was going to do right there is put that in parentheses. Factor out the GCF if possible. The only problem is that sometimes it might not be easy for you guys to tell whether or not it's possible, okay? So that comes with the territory here, okay? Factor out the greatest common factor. Okay, obviously 3 is 3 times 1, 2 is 2 times 1, 1 is 1 times 1. There's no common factor here, okay? Sometimes you might have to investigate the numbers a little bit, try to divide them and figure it out, but it's not always possible. Then, after that, once you factor out the greatest common factor, then we factor the new polynomial, okay? We just factor the polynomial is what I really say to kind of symbolize that next step. Okay, whether or not you were able to factor out the greatest common factor, factor out the polynomial that you have. After that, we set each factor equal to 0, and then we solve. Okay, solve each of those equations that we get. So I took a moment to write you guys a list of things that probably would already be in your notes, but because it's the final, I decided that maybe you guys should realize that this would be a list of things that would help you get through solving by factoring. So what I want to do right now is, basically finish this problem, okay? And I know I'm gonna have to erase all of it basically. So if you guys could just, live with that for now. If you gotta, copy the rest of this list, just go ahead and copy it down, rewind the video. Okay, but for now I'm gonna have to get rid of these and we'll finish up this problem and we'll move on to do some other kind of things in a second. Alright, this video is running on the longer side, and so I know some people are going to skip around and try to find the problems that they're looking for. So that's fine if that's you. If this problem is something that you're not worried about, that's good. Otherwise, stay tuned and we'll finish up this problem together. So, like I said, there was no greatest common factor. So our next step in this case was going to be to go ahead and continue. You draw the magic X, we do what we got to do. So let's just work down here for now. Okay, we're going to use our magic X method and we're looking for our A and our C. Two numbers have to multiply up to that and add up to B, right? Okay, B in this case is a -2. And C in this case would give us -3. And I think we covered that. Okay, sorry. So the next thing that we actually want to do, since we already did that work, the one thing that I did is, I confused myself for a second because what I try to do is help you guys get that list of numbers. So obviously, you guys can see. We just did that a second ago. Okay, so right now what we would do is use the values that we got to factor this polynomial. So we have our two factors. Okay, we write this one, we write the second one, and we go put everything where it goes. Okay, we remember that this is a 1 right here. And so in this case, we have a coefficient that's of the variable that's going to be 1. So that gives me that I have to have an x plus 1 in one of these. And then this other one, the leading coefficient, will give us basically, you know, do we think of it as a -3, right? So if I had -3x, what would happen if this was plus 1? Is this going to be correct, right? If I do 1 times +1, does that give me a +1 like we need? Okay. And if I do x times -3x, does that give me -3x squared, right? And if I do 1 times -3x, that would give me -3x, and I'd add this other x times the 1. So when we have a leading coefficient that's negative, you have to make sure that you're dealing with that correctly and make sure you factor it right. And so in this case, we have two factors now. And then you just set them both equal to 0 like we did before. And solving each of these is a little minor sub-step that you have to do here, right? We take away 1 from both sides, and we get x minus 1. On this side, if we take away 1 from both sides, then we will get -3x equals -1. If we take we divide both sides by -3, then we get x equals 1 over 3. So we would be looking for the one that has a -1 and a 1 over 3, and we see that that option is option D. So we have a little bit more review to do. We have the end of the review, and I believe I covered some of these depending on which class you were in. Some people ask different questions. So solving an equation by taking square roots. We'll wrap this up. I know this video might be on the longer side, but you know, it's up to you whether or not you want to watch it. So skip around and get to the problem that you want to cover, but I'm going to try to hit all of them. Okay, we got a squared equals 81. So we would solve this by taking square roots, which means you take the square root of both sides. Okay, so the square root of a squared is a. And in this case, like I said, when you take the square root, we always have our plus or minus. In this case, that would be 9. Okay, so we find our answer as plus or minus 9, and that would be B, where we have positive or -9. On 24, you know, as we saw before, we didn't want you guys to confuse this with solving by factoring, so you got to be careful about that. We have this equation, n squared plus 3 equals 84. In this case, we would not want to take 84 from both sides because we're not solving by factoring. We're solving by taking square roots. So in this case, we will isolate the variable. So that's why I get rid of this thing on the left side, because it's with the variable. I want to move everything else that's not variables to the other side. 84 minus 3 is also 81. And now if I take the square root of both sides, we see that we get the same answer as the last time, where we get plus or minus 9. Because, again, the square root of 81 is 9, because 9 times 9 makes 81. So I'm not going to go over too much. If you need to study more square roots, you could watch a different video. But we'll try this one right here. All right. We would take a look at this equation. 7n squared minus 1 equals -101. And then what we could do is add 1 to both sides. Again, when we try to solve this problem, we are not trying to set it equal to 0 because we're not solving by factoring. We're solving by taking square roots because that's what the problem asks us to do. So -101 plus 1 equals -100. Do not say at this point in the semester that we have -102. Okay. Well, the very next thing that we would do is divide both sides by 7. And we could do that. But we can see at this step, we're going to end up having to take the square root of a negative number. And when you have to take the square root of a negative number, we've learned about something since we learned the quadratic formula, okay? We've learned that we have to use an imaginary number in this case, right? So since we would have n, right, the square root of n squared is n. That's why we took the square root in all of these last steps, because we want to get rid of the square. And so we take the square root. But on the right-hand side, we have a negative number underneath a square root. So the best thing that we would be able to do would call this I, we'd have our plus or minus and all of that we usually have when we take a square root, yeah? But in this case, underneath the square root, we would have 100 over 7, which is 10 times 10 over 7, right? And then the best we could do would be able to factor out that repeated factor of a 10 outside. So, I mean, again, look, none of these are here. There's no imaginary number. So we don't want to be barking up the wrong tree here. There's no imaginary number. We're taking the square root of a negative number, and there's no imaginary number. So that means in this case, we would want to choose no solution. These other ones could not possibly be the answer. So we'll move on to this next section of solving equations with the quadratic formula. All right, and we don't want to do too much of this because we just did a lot of it, obviously. But if you had trouble, then hopefully just refreshing our memory. It's been maybe a longer weekend. Maybe it was a short weekend for you. All right, but either way, using the quadratic formula, we said step 1 would be, right, that we see that it's already set equal to 0, right? We called that step 0, right? Step 0 was make sure that the equation is set equal to 0. This one is set equal to 0. So now we can start, okay? And in this case, we would say that b must be equal to the square root of negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, and then I taught you guys to just put the equal sign and change these into a bunch of blank parentheses. Okay, and all of that goes underneath the square root. And then we have 2a, another blank parenthesis. So what numbers go in here, okay? In this case, we have to realize that our a represents the coefficient of the quadratic term, and that's 1. B represents the coefficient of the linear term, and that's 1. And C represents negative 6. So we put all these numbers where they go. What goes in this place? The value of B, which is a negative 1. So like we always did that, right? We would write A equals 1. B, what's B equal to? What's C equal to? We would write all of these values here, right? We would say that A equals 1, B equals negative 1, and C equals negative 6. So we just go put the numbers where they go. Negative 1 goes in this spot. A goes here because that's 1. And negative 6 goes right in there. And in this case, we would have 1 on bottom here. So now we would just simplify, right? Negative 1 makes positive 1, plus or minus the square root of negative 1 squared, which gives us 1. And this was where we had trouble. Okay, 2 times 1 is 2, but what number do I go right in here? And this is where I told everybody to go do 4AC somewhere off to the side. Go do 4AC somewhere else so that you don't get confused by this process, okay? This says 4AC, right? That's what we're supposed to subtract. We're supposed to subtract 4AC from b squared. B squared minus 4AC. So this is b squared. There's the minus. What goes in here is 4AC. 4 times a is 1, right? 4 times 1 is 4. And 4 times negative 6 makes negative 24. So that means what I have to plug in here is negative 24. So if you can get through that, I'm telling you, doing the 4AC on the side will save you from that little problem. Okay, minus negative 24 means to add 24, right? And so now we can see that what's going on here is that we have a sum, right? We're going to add these values up together. So now we can continue working, and we can see that we have 1 plus or minus the square root of 25 all over 2. And now when we finish this up, we can realize that the square root of 25 is 5. Okay, and that's over 2. So we have 2 possible values that we get, right? We would get 1 plus 5 over 2, or we have 1 minus 5 over 2. Okay, it could be up to you how you want to make this work look. You can keep working horizontally or vertically, either way. Just organize your work, fit it somewhere. Okay, 1 plus 5 is 6 over 2, or 1 minus 5 is negative 4 over 2. 6 over 2 is 3. And in this case, we'd have negative 2. So you get your 2 answers there, right? So we go back and look. Do we have 3 or negative 2 in our choices? And we see that that would be option B right here, right? We can choose option B to be our solution. Okay? So now what we can do is go take a look at this last review problem that we have. And, you know, luckily for you students, you have a graphing project. And so some of you guys should be reviewing graphing right now anyway. And so I'm hoping that some of the multiple choice graphing problems on this test are not going to be that troublesome for you. But if you were having trouble with graphing, and I'm going to say this before right now, if you're having trouble with graphing, go watch one of the graphing videos right now. Rather than have this video go run an hour and a half, okay? Go watch one of the videos about vertex form, factored form, standard form. You'll only have to watch 1 or 2 examples. You don't have to watch the whole video, but it should be enough to refresh your memory. There's going to be graphing on the test a little bit. There's going to be multiple choice, of course. And so you're going to want to refresh your memory for all those things, right? So if we look at this problem right here, it's already set equal to 0. We can solve 27. We got A equals 2. We have B equals negative 1, right? An invisible 1 right here. And C equals negative 4. Okay? We know when we do the square root, and like I was telling you guys before, this is a multiple choice problem, so we could try to save some work, right? Save some time. We know that the quadratic formula is going to give us negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, once upon a time when I told you this, you guys thought I was ridiculous for assuming that you guys would ever memorize this, but most of you guys, I think, have it down now. And this part underneath the square root is called what? This is called the discriminant, right? We use this for some purposes, right? To find out how many solutions that we have, and it can also kind of tell us where our vertex is going to be, right? Is it going to be sitting on the x-axis? Is it going to be above? Is it going to be below? Where's, you know, how many x-intercepts are we going to have? There's a lot of things that this value tells us, okay? So the discriminant, we see that's the part that goes under the square root. So we can kind of think about this for a second. Maybe that could help us eliminate something, but think about it. If I know that the first thing I'm going to do is calculate negative 1, because b is equal to negative 1. What's negative 1? That means my next step, I'm going to simplify that to positive 1. So that tells me it can't possibly be a, because there's a negative 1 there, and I would have to change that to positive 1. Okay, but now we got to rule out one of these two. We got to think about that. Okay, well, if we keep going to work, we can see that, of course, we'd have to square negative 1 and then do minus 4ac. Well, a is 2 and c is negative 4. And so now we have all of this over 2 times a, and a is 2. So we could keep working and just finish this up, right? Negative 1 is 1. We have negative 1 squared, which just becomes 1. And then, like I always tell you guys, put that blank parentheses there. and put the result of multiplying 4 times a times c right there. 4 times a is 2. Sorry, 4, yeah, a is 2, and 4 times 2 is 8, right? And then 8 times negative 4 gives us negative 32. And now we can see maybe where this 33 is coming from, because minus negative 32, what does that mean? Right? To subtract a negative means to add. And so this is really saying that we have to do 1 plus 32 over 4. And we could see that 1 plus 32 gives us 33. And that looks exactly like what we have here, where we will have to add it one time and we'll have to subtract it one time. So you should be able to see that your answer is D, and go move on and work on the rest of your test. So, you know, this video is just a little under an hour. I hope you guys made a notes page, and, you know, if you're just checking out to see what the answers is and using this video as an answer key, that's also fine. But, you know, hopefully you found a couple problems that you might want to go explore a little further. So some of you guys have finals tomorrow. Some of you guys got a couple days. Use this this video to get through. I hope it has some kind of value to you. As I told you, the next thing that you would want to do would be to review graphing, which is one thing we didn't get to. Like in this video earlier today, I reviewed pretty much adding and subtracting polynomials and multiplying with every class. In this video, we covered factoring, solving my square roots, the quadratic formula. The one thing that you guys need to do now is review graphing, okay? All of the forms. Okay, so you guys should remember vertex form. You should put that in your notes. You should remember standard form. And this is what I was saying in the note page video, by making a table, right? Maybe you could break this down so that you don't get confused between all the forms, right? Vertex form is where we had maybe something that looks like this, something that I hope you guys are used to seeing in your project, okay? In this case, we would have a vertex that is at +2 and +1, okay? Whereas in standard form, this is what we use all the time when we're working with the quadratic formula, okay? And in this case, the x coordinate of the vertex is x equals negative b over 2a. Okay, and then when we wanted to find out what the y coordinate of the vertex is, right? What would we do? We wanted to find the y coordinate of the vertex, then we would go plug that in to our actual equation, right? So that was a process that some of you guys got down. Some people kind of just left that one behind. But, you know, factored form would be something like x equals -2, x minus 2 times x minus 3. And in factored form, we notice that this is also called intercept form, because when we look at this, this gives us the x-intercepts, okay, as long as we change the sign of these two numbers. These x-intercepts would be at x equals +2 and x equals +3, okay? So these equations are all very different, right? We know that in vertex form, the first thing we would do would be go plot the vertex and then figure out how to deal with our leading coefficient, right? Do we go over 1 and up 1 squared? Do we go over 1 and up 2 squared? You know, do we go over 1 and up 3 times 1 squared? All those different values that we did before. There was an assignment called Graphing with Leading Coefficients that we did to cover this topic, okay? I have videos on each one of these forms, right? Vertex form, standard form, okay, factored form. if you feel like you want to attack graphing right now, watch those videos and try to understand that, there's a lot of other things to cover. So, if graphing always kind of confused you, deal with, another topic maybe. But I wouldn't leave it out totally, you know what I mean? If the standard form was the one I could never get, should you spend the next hour only working on standard form so that you can get 1 point? I'm not sure. There might not be so many that are on that topic. So, like I said, pick your battles. Obviously, if there's a few different areas where you struggle, then yeah, you got to think about something, okay? But you certainly should know what a vertex is, and you should remember what an axis of symmetry is, okay? All of these things are only going to help you more if you go ahead and watch one of these videos where you'll understand how to do each one of these forms. So the video is at an hour long now. I'm going to go ahead and cut it off and upload it. Good luck to you guys on finals.